D and F block element is one of the important chapter in 12th chemistry. Here are some of the most important points for the coming NEET exam. So D block elements are also called as transition elements. Now in D block elements you can find four series. It starts with fourth period, 3D series, fifth period has 4D series, sixth period has 5D series and seventh period has 6D series. So 3D series, you remember 3D series starts with scandium to zinc and 4D series starts with yttrium to cadmium. The general electronic configuration of D block element n-1 D1 to 10 ns 1 to 2. This is the general electronic configuration. Remember, transition element shows variable oxidation states. Variable, not just one. You can find more than one type of oxidation state because it has incompletely filled outermost d orbital. And highest oxidation number in each series, if you find in 3D series +7 for manganese, in 4D series +8 for rutherfordium, and in 5D series +8 for osmium. So transition elements highest oxidation state is +8. And you can find some of the complexes where transition element has zero oxidation state. For example, in the complex NiCO4 times, nickel has zero oxidation state. In FeCO5 times, here also iron has zero oxidation state. Next is magnetic property of D block element. If you find unpaired electrons, then they are paramagnetic. If unpaired electrons are absent, they are diamagnetic. So usually D block elements are paramagnetic in nature because they have some one or more unpaired electron. Because of that, they have a tendency to attract the magnet. So the magnetic moment is calculated by spin only formula. This is spin only formula where magnetic moment is equal to root of n into n plus 2 Bohr's magneton. Bohr's magneton is the unit and n is the number of unpaired electrons. Another most important point here is transition elements are colored, and the reason is the unpaired electrons in the transition elements undergo D to D transition. Because of D to D transition, they are colored. In transition elements, we can also find complex compounds. Transition metals can form complex compound because of their small size and vacant d orbital. These two reasons are responsible for the formation of complex compound. And transition element shows catalytic property also because of variable oxidation state, vacant d orbital and free valency. For example, vanadium pentoxide used in contact process to manufacture sulfuric acid, iron is used in Haber's process to manufacture ammonia, platinum is used in Oswald process to manufacture nitric acid, and nickel is used in hydrogenation of oil. Then also remember zinc ion Zn2 plus ion and scandium Sc3 plus ion are colorless because they don't find any unpaired electron. Transition metal also form interstitial compounds like TIC. For example, here in interstitial compounds, small atoms like hydrogen, carbon, or nitrogen, they fit into the void, empty space of transition metal. And the properties of transition metal, interstitial compounds, they have high melting point, hard and have inertness, and retains metallic conductivity. These are the properties of interstitial compounds. So transition elements can also form alloys. The main reason here is that the transition elements can form alloys because they have almost the same size. For example, brass is the alloy of copper and zinc. Bronze is the alloy of copper and tin. And mercury, when you find mercury metal, then the alloy is going to be called as amalgam. So with gold, silver, tin, but not with iron and platinum. Mercury can form amalgam with gold, silver and tin, but mercury cannot form amalgam with iron and platinum because they are reactive. And zinc, in 3D series, zinc do not show variable oxidation state. It has only one oxidation state, that is +2. And lithium, sodium, iron, mercury, they cannot form an alloy. And alnico is also the name of an alloy which is a permanent magnet. It includes aluminium, nickel and cobalt. And also remember 24 karat is 100% gold. Remember, the most abundant transition element is iron, and tungsten has highest melting point. Atomic in 3D series, atomic size decreases from scandium to zinc, and in 3D series, SC3 plus, Ti4 plus, and Zn2 plus. These are the ions does not carry any unpaired electron. That's why they are diamagnetic in nature. And Ni2 plus and Cu2 plus are paramagnetic due to the presence of unpaired electrons. Next, you remember F minus fluoride ion has high enthalpy of hydration, and F minus can stabilize the highest oxidation state of metal. Fluoride ion can stabilize the highest oxidation state of metal. When you look at the variable oxidation state of iron, that is Fe2 plus and Fe3 plus, Fe2 plus has a 3d6 electronic configuration, and Fe3 plus has 3d5 half-filled stable electronic configuration. Because of that, third ionization enthalpy is very much higher. So second ionization enthalpy is higher because of it is going to disturb the d5 electronic configuration compared to the most, this one Fe3 plus is the most stable one because of d5 electronic configuration. And third ionization enthalpy is smaller when compared to second ionization enthalpy, because third ionization enthalpy leads to d5 most stable electronic configuration. When you see the oxide nature, MnO having +2 oxidation state, and remember, low oxidation state are basic in nature. In Mn2O7 it has +7 oxidation state, in Mn2O3 +6. So high oxidation state leads to acidic metallic oxide, whereas MnO2 has +4 oxidation state, it is amphoteric. Remember, MnO2 is amphoteric, neither base, it has a property of both basic oxide and acidic oxide. Then in the conversion of manganese from manganese to Mn2 plus, in Mn2 plus manganese attains stable d5 electronic configuration. That's why Mn2 plus is the most stable oxidation state in manganese. And in chromium, Cr plus 6 is more oxidizing than Cr plus 3 because of its stability nature. From chromium to nickel, the number of unpaired electrons are going to decrease and the number of bonds are going to increase. And coinage metal, remember, coinage metal includes transition metals like copper, gold, and silver. Copper, silver, and gold are the coinage metals. So potassium dichromate K2Cr2O7 can be manufactured from the ore called ferrochrome or chromite ore, whose formula is FeCr2O4 or FeOCr2O3. And here you remember, in this ore, iron oxidation state is +2 and chromium oxidation state is +3. And also remember, potassium dichromate is a strong oxidizing agent, and it is responsible for the conversion of oxidation of Fe2 plus to Fe3 plus, I minus to iodine, H2S to sulfur, and Sn2 plus to Sn4 plus. Next, you remember the when you decompose potassium dichromate K2Cr2O7, which is orange in color, it converts to potassium chromate K2Cr4, which is yellow in color, along with the formation of Cr2O3, which is green chromic oxide with the release of oxygen gas. And also Cr2O7 2 minus dichromate ion in the presence of alkali medium, basic medium, it converts to CrO4 2 minus chromate ion, and chromate ion in the acidic medium converts to dichromate. This interconversion also you need to remember. And ammonium dichromate on decomposition, it converts to ammonium chromate and the formation of green color chromic oxide with the release of oxygen gas. And potassium permanganate formula KMnO4. To prepare potassium permanganate, we can use MnO4, which is a MnO2 pyrolusite or MnO2. And when you decompose potassium permanganate, which is deep purple color, at 513 Kelvin, it will convert to potassium manganate, green color potassium manganate K2MnO4, along with the formation of brown color MnO2. And in the preparation of potassium permanganate, carbon dioxide gas is added to remove the basic OH minus ion. So for the conversion of Mn plus 7 to Mn plus 6, alkaline condition is required, and potassium permanganate can oxidize MnO4 minus to Mn2 plus, I minus to iodine, oxalate ion to carbon dioxide, Fe2 plus to Fe3 plus, and sulfide ion to sulfur. So remember, if in case of vanadium, V2O3 is basic, V2O4 is less basic, whereas V2O5 most important is amphoteric. Similarly, in case of chromium also, Cr2O3 is amphoteric, CrO is basic, and CrO3 is acidic in nature. F block elements are also called as inner transition elements. The general electronic configuration is N-1 0 to 14, N-1 0 to 2, Ns2. So it has two series, 4F series and 5F series. 4F series starts with cerium to lutetium, and atomic and ionic radii decreases, which is called as lanthanide contraction, and due to lanthanide contraction, basicity and electronegativity is going to decrease, and atomic radii of zirconium and hafnium is almost the same. Because of that, it is difficult to separate them. So lanthanide includes 14 elements. The common oxidation state is +3, and one of the lanthanide, that is cerium, it shows +4 oxidation state because of its to attain the stability. Then remember the composition of mish metal. It has approximately 95% of lanthanides, 5% of iron, and traces of carbon, sulfur, aluminum, and calcium. Another series of F block is actinide, which includes 5F series. It is also having 14 elements from thorium to leverancium. And uranium is also one of the actinide, and atomic number 93 onwards you can find trans uranium elements, which are man-made or synthetic in nature. So here also we can find in decrease in atomic and ionic radii, which is called as actinide contraction. And remember, all the actinides are radioactive. The most common oxidation state in actinides also +3. So here you can find more number of oxidation state compared to lanthanides because of low energy between 5F and 6D. So here you can find the electronic configuration of 3D series elements from scandium to zinc, and you can find the number of unpaired electrons are going to increase first. Highest number of unpaired electrons you can find in chromium, that is 6 unpaired electrons, and then number of unpaired electrons decreases. In zinc you cannot find any unpaired electrons, 0 unpaired electrons here. And remember, borodox is a fungicide, and verdigris is a copper corrosion product. So here this is the important points of D and F block elements. I hope it is going to be useful to you. Thank you.